Hi everybody, Mrs. Tan here again, and I'm going to go over section 1.4, Measuring and Classifying Angles. So an angle consists of two rays that have the same endpoint. So an angle has a vertex, so in this case our vertex would be point C. It also has two sides. Those sides are rays. So here, ray CT and ray CL are the sides of the angle. And the angle really consists of the space between these rays. So if the angle gets bigger by having the rays separate more and more, then the degree of the angle gets larger. Or if you put the rays closer and closer together, then the degree of the angle would be smaller. So there are three ways that we name an angle. The first way, which is the easiest way, is just naming it by its vertex. So you could name your angle C, and that would be good enough to name this angle. You can also name it with three letters. So you can trace it with your pencil and think about how, when you trace it, in which direction you would go. So it would be T, C, L. So from T to C to L would be another acceptable name to name this angle. You can also trace it the other way. So you could say L, C, T. Notice that the vertex is always in the middle. And that's because the vertex is always like the second point that you get to. So if you start from L to C to T, there's your vertex, or T to C to L, there's your vertex. I could not name this angle CLT because that would imply that L was the vertex, and it's not. Now, if we could just name every angle by its vertex, then why would we even need these other two options? Well, let's think about it. Could we name any angle by its vertex? What about this angle? Could we name this angle just angle B? Would you know what angle I was talking about if I told you angle B is my favorite angle? Would you know which favorite angle I was talking about? No. So you can't always name an angle with one letter. What do I mean if I reference angle B? I don't know. It could be any of three different angles, right? It could be ABD, it could be ABC, or it could be CBD. So here, you would have to name it with three letters in this case. But TCL, you could just name angle C. You can name angles, and you can also classify those angles. So an angle can be classified as acute, less than 90, obtuse, which is greater than 90, straight, which would be equal to 180, or right, which the measure would be equal to exactly 90. So here's the difference between naming something and classifying something and measuring something. So you could say, hi, my name is angle ABC. That's my name. My measure is 75 degrees. And my classification is acute. And I'm acute because I'm less than 90 degrees. So to measure an angle using a protractor, you can try using an actual real protractor at home, but because we're all online right now, we're going to try just using images of protractors, which is probably what you're going to have on NJSLA anyway. So in order to read a protractor, you would first start by lining up the vertex of your angle with this little like T right here, upside down T. So the vertex has to be lined up exactly right here. And then one side of the angle, so one of the rays here, needs to be lined up perfectly with the 0 degree line. Okay, so when you're reading the protractor from right to left, so when you're starting here and you're going to the left, then you're going to read the numbers that are closest to the vertex. So think about you're going from this side here, and then you're going up by 10, 20, 30, and then a little bit more than 30. So it looks like exactly halfway between 40 and 30, which would mean that the measure of this angle is 35. So let's look at another one. This angle is obtuse. And you can see here that it's lined up perfectly. We have this ray here starting at 0. And then here we're going around. And if we're going above 90, right, so this is bigger than a right angle, which means it must be obtuse. We're going to continue to 100, 110, 120. It's past 125, 126, 127 it looks like. So the measure of this angle would be 127, and it would definitely not be 53. How do I know that? How do I know not to look at this top number? It's because just by looking at this angle, I know it's obtuse. So it would have to be between 120 and 130, and it's 127. Okay, so now I want you guys to figure out the measure of this angle. Okay, so next we're going to talk about the angle addition postulate. Angles that are next to each other add up to equal the full angle. So just like the segment addition postulate, angle addition postulate is also a thing. So that would mean that the measure of angle ABC plus the measure of angle CBD is equal to the measure of angle ABC. So the two smaller angles are going to add up to the largest angle if those two angles are adjacent. Adjacent means next to each other and they share a common side. So these two angles share a common side. You can add them up and equal them to the whole. Okay, so I want you guys to try and name the angles in the figure. So try and name, there are 3 different angles in the figure. There's a larger angle, there's a medium angle, and there's a small angle. Name those 3 angles. Okay, so you should have gotten that the larger angle, you could have said it was either CDF or FDC. Either one would have been fine. You couldn't just name it angle D because I don't know which angle D you're talking about. The medium angle, you should have gotten either CDE or angle EDC. And for the small angle, you should have gotten angle EDF or FDE. Now, in the figure to the left, if I know that CDE, the measure of angle CDE, is 62 degrees, notice here if I'm trying to talk about the measure of an angle, I put this M in front. The M in front means that you're looking at the measure of the angle and not the name of the angle. So the measure of angle CDE is 62, and the measure of angle EDF is 18. So let's label that there in our diagram. We want to find the measure of angle CDF. So first I'm going to set up my angle addition postulate. I'm going to say that measure of angle CDF is equal to the measure of angle CDE plus the measure of angle EDF. Notice again that I have the measures in front because you're talking about adding the measures of an angle. You're not talking about adding the angles themselves. So if I just said angle CDF equals angle CDE, that plus angle EDF, that would make no sense. That would be like saying chair plus chair equals something, right? You can't add objects. You can only add the measure of those objects. So that's where the M needs to come in. So then you have measure of angle CDF. You're going to substitute 62 and 18. Then you can simplify that and say that measure of CDF is equal to 80 degrees. Okay, so given point P is on the interior of RST, angle RST, the measure of RSP is 59 degrees, and the measure of PST is 7 plus 3x, and the measure of RST, the whole angle, is 9x plus 12. Solve for x and find the measure of RST. So I'm going to start you out with this one. Let's draw this, the first part, out together. So you should be drawing this on your notes sheet. So we have angle R ST. P is on the interior. When something is on the interior, it just means it's in between the two rays of the angle. So it could be anywhere on the interior. It doesn't have to be exactly in the middle. So here you should have this diagram labeled. Now I want you to try to do the rest of the problem on your own. So I want you to solve for x and also find the measure of RST. Okay. So you should have labeled in your diagram that this angle here was 59 and this was 7 plus 3x, and the total angle was 9x plus 12. So you should have gotten this equation, which is 59 plus 7 plus 3x equals the total 9x plus 12. You simplify, combine like terms, and you get 9 equals x or x equals 9. Once you find the value of x, then you can plug it back into the expression for RST, and you should have gotten 93 degrees. So if you did, great job. If you didn't, hopefully you understand it now. So now let's talk about congruent angles. So congruent angles are angles that appear the same. So if you took one angle, this angle A, and you placed it right on top of angle B, they would be the exact same measure. So if you put them on top of each other, they would be the exact same. They would look exactly the same. We mark congruent angles with these swoops. So the swoop here and the swoop here, that single swoop tells us that these two angles are congruent. So with segments, we mark them with tick marks, but with angles, we mark them with swoops. So it's kind of a fun word to say. So say it with me, swoop. Okay. And that's how we would mark congruent angles. You can also state that angle A is congruent to angle B. So the objects themselves are congruent, or you can state that their measures are equal. So the measure of angle A is equal to the measure of angle B. Also, an angle bisector is a ray, a line, a segment, or a segment that divides an angle into two congruent parts. So just like you can bisect a segment, you can bisect an angle. It's kind of like taking a slice of pizza and splitting it in half. Okay, so let's try this example together. We have JK bisects HJL. So let's draw this out. So we have angle HJL, and then we know that JK bisects that angle. I'm going to mark that using swoops. So I have a swoop here and a swoop here, and those swoops tell me that this is an angle bisector because these two angles are congruent. Now it says, given that the measure of angle HJL is 42, what are the measures of HJK and KJL? So if this entire angle is 42, then think about what the measure of each smaller angle would be if we know that that angle is getting split in half. So if you got the measure of HJK is 21 and the measure of KJL is 21, then you're right. Okay, so the last problem we're going to talk about is we're going to decide whether the statement is always, sometimes, or never true. And let's explain our reasoning. So the first one, it says a pair of opposite rays form a straight angle. A pair of opposite rays. So remember that opposite rays are rays that have the same endpoint, but they go in opposite directions. So this one is always true. Opposite rays will always form a straight angle. Okay, the next one. The measures of two acute angles add up to 90 degrees. So would the measure of any two acute angles add up to 90 degrees? Is that possible? And if so, does it happen always, sometimes, or does it never happen? So this would be sometimes. For example, 30 and 20 are both acute angles and they don't add up to 90, but there are plenty of examples where two acute angles would add up to 90. For C, it says, if C is on the interior of angle ABD, then angle ABC is congruent to angle CBD. I want you guys to sketch this one out. So sketch out angle ADB, and then put C somewhere on the interior. Then draw ray DC. Would ADC, that angle, always, sometimes, or never be congruent to CDB? So the answer is sometimes. So if you put C anywhere on the interior, that doesn't mean exactly in the middle. It just means somewhere on the interior. So you could have the angles not be congruent, or they could be congruent, right? So you can have an example where it's 30 and 30, but sometimes they're not congruent. So this would be sometimes. And then for D, it says, when a ray bisects a straight angle, two congruent acute angles are formed. So if you have a ray and it's bisecting a straight angle looks like that. If you bisect it, do you sometimes, always, or never get two acute angles formed? So this would be never, because when you bisect a straight angle, you're going to form two right angles, not two acute angles. And that's it.